It means both ways. Yeah, if and only if. One of them implies the other. If y equals log base a of x, then a to the y equals x. They are the same. They are the same. Just for terminology, this right here is called the log form. And the other side is called the, anybody know? Exponential form. One is called the log form. The other one is called the exponential form. Great. Okay, why is this useful? Well, we've dealt with it a little bit before. I could ask now. Well, you've dealt with logs before. You've seen log. This is not a totally new thing for you. You kind of grown because you don't like them, but that's just how it is. Right now, if I gave you y equals log base a of x and asked you a question, that would be the standard question. What is the derivative of y? You don't quite know how to do that. But now, because I just reminded you of the definition of logarithm, what can you do to this logarithmic expression right there? How can you rewrite it? We're rewriting it. We're not really substituting anything. We're rewriting it, but you're absolutely right. We have a definition we can use. This means that's true as long as this is true. Now what can we do to this thing? We can now do what? Now we're going to take the derivative. Absolutely. What kind of differentiation do we need to use? What? Implicit differentiation. What's the derivative of the left? ln a times y prime is equal to what? Nope. 1. We're trying to isolate y prime, so we isolate y prime by dividing. 1 over ln a to the y. Exactly. Exactly. So we just figured out what the derivative of y is if y is equal to, not ln, log base a of x. There it is, right there. For example, let's say I said j, so 2 bars means like a break. That means I'm going to go to a new idea. J of x is equal to log base 7 of x. Can someone tell me what j prime of x is? Anybody? 1 over ln to the what? Times what?
7j of x.
7 to the
j of x or y, whatever.
j of x? Why are you saying j of x?
Because that's the y value.
Okay, hold on a sec. That's absolutely correct, but we need to do some simplification. Namely, which piece bothers you? This bothers you, right? That's 7 to the log base 7 of x. Let's say we didn't know what that equals. This right here is exponential form. If we have something in exponential form, what can we translate it into? Log form. So let's actually translate this back into log form and see what happens. Here's log form. And that didn't really help me. Y equals log base a of x, if and only if what is true? A to the. So if this is exponential form, what's the base of this power here? What's the base? 7. What's the power? Log base 7 of x. So what does this turn into if we do this log? We do log base what? 7 of. Log base 7 of. This is a little challenging. A to the y, like this, equals log base 7 of x. This right here is the same thing. But if log base 7 of question mark equals log base 7 of x, what has to be true? What has to be true? Question mark equals x. So let's go back and look at our definition here. We came up with this definition right here. That's technically true, but we don't really like that y being in there. We know that a to the y is equal to x. We know that log base a of x is equal to y. These are the same thing. So what do we plug in for y? We take this thing right here and we plug it in right there. So let's do the general form. Y prime is equal to 1 over ln of a times a to the what power?
Log base.
Log base a of x. But here's something that's always true. A to the log base a of x, what's that always equal to?
X.
X. So what does this simplify to? Y prime is equal to 1 over ln a times x. Yay! So don't move, kids. So if y equals log base a of x, y prime is equal to 1 over x ln a. That's what we just came up with right here. I will put the homework down at the bottom of this document.